What did you say? You wanted to, you didn't get the number all written down? Okay. Okay, you got it. It's there. Well, the theory is we're pretending, the setup is that it hasn't happened yet. So we're sort of pretending that we're back in time 7 years ago, and we want to know like when approximately we should download some apps to see if we can be the 25 billionth one. Okay. Right, but we don't want to just sit here for days just watching that counter. It does go up pretty fast, yeah. So do you guys have the information you need written down from this page? All right. If you want me to pause it or go around again or anything that you want, just let me know and I'll do that. Okay. Pause it at the end. Oh, okay. Where's my pause button? Oh, missed it. Pause it at the end. Okay, ready? There, pause it at the end. Does that help you? I'm having, it's got a little counter on the bottom that says how many seconds. How's that? Is that close enough to the end? I think if I go, yeah, if I go one more from there, it won't. Oh, oh, okay. You would think, huh? Okay, that's as close as I can get to the end. And that was a 8 second clip. Okay? What's that? That's all I got. Okay? Uh-huh. All right. How long do you need to figure this out? How much time do you need? 10 minutes enough? 10 minutes is enough? Okay. Right. So, yeah, because it's only 8 seconds, and so you're obviously not going to be able to get this like exact. You're right, because this counter only goes by minutes, and this one went by seconds. Yeah. So you're just going to get, a, yeah, middle drawer. There might be one. If there's not, try the one on your. You got one. Okay. The video was from 2012. Okay. Did you just say the like the month and the day? Okay. All right. So on February 13th, 2012, Apple announced the 25 billion app countdown promotion, which would award 10,000 US dollar iTunes store gift card to the person who downloaded the 25 billionth app. And then we did that, and then we did that. Watch the video clip. Okay. And you did that, 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 and you did nothing, and you did nothing, and she did nothing. So there we go. All right. So what's happening now? You guys don't have this sheet, do you, or do you? You just said no without even like looking. Isn't that is it different? Oh, you don't. Okay. Okay. So this is the kind of math that maybe you would do to figure this out. This is what the graph kind of looked like. This doesn't have the answer because it doesn't go far enough. But built in assumption in all the work that you guys were doing is what is true about the data. It's going up in what particular way? In a steady line, yeah. So you all assumed, and you were right because this is a graph of the data and you can see that it's going up the same amount all the time, okay? Which, you know, maybe you would think that wouldn't be the case because maybe at nighttime there wouldn't be people as right, but then there's people in other parts of the world who are awake, and so it apparently all balances out, and it works out to be a pretty darn straight line. Okay. Well, sure, you could use it on the App Store because you just type in the code and they know the code, and so it doesn't really matter. Yeah, so it wouldn't matter where. It wouldn't matter where you were when you got it, okay? All right, so we're skipping this. I didn't give you guys this plate. Okay, but we're doing this. All right, so the first thing, a little activity we're going to do today is I'm going to pair you guys up, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to give you some cards, okay? You're going to place the cards face down on the table in between you and your partner, all right? And you're going to take turns flipping one over, and you're going to look at that, and you're going to say whether it is the thing on that card represents a function, yes or no, okay? And then the next person is going to draw a card and do the same thing. And if you're not sure, I'm sure none of you, you'll know all of them because you're such great math students, but if you're not sure, for whatever reason, you can make a new pile for not sure ones. Yeah. To the download thingy? Yeah, do you want to know? Okay, I'll give you guys the answer when you're set up and working on this, okay? All right, so first the bad news. The bad news is y'all got zeroed out because it's the end of the semester, so we're rolling over our Dojo points, okay? The other bad news is we've lost some good people out there. So yeah, R.I.P. Lindsay, and also R.I.P. Riley. We're not removing Alexa from class because it sounds like she might stick it out. All right, so what I'm going to do is I'm going to give you a partner. The person, well, we'll just see. We're going to go group maker, and we're going to go 2. Okay, so Dylan and Weston, will you guys work together? Jaron and Talia, will you guys work together? Matthew and Luis will be working together, and Alexa and Nathan. Okay. All right, Dylan, tell me one of them that you know is a function. Yeah, what was one that C, you said yes. Okay. All right. Everybody get yes for C? Does anybody want to disagree? You got yes? No? Feel good about that? How did you know that was a function? What made you think that? The vertical, oh, it is a straight line. So all straight lines are functions? And it's also going up. Okay, in what case would a straight line not be a function? What's that? Do you guys agree that if a line is going down, it's not a function? Still be a function. Matthew, can you give me an example of a straight line that is not a function? Luis? Straight up and down. Okay, good. The only straight line that is not a function is one that's going vertically straight up and down. Okay? And that's because this would fail what we like to call the vertical line test. Okay? So yeah, you're right. That is a function. Okay? Okay, Weston, give me one that you knew as a function. What one did you put as yes? Anything? Oh, that's the only one that you... X. Oh, I see what you're thinking. Not of those 4, right? Of anything. Okay. What made you think that x was a function? Okay. So this is like one of the... Matthew? Shut up. This is one of the patterns that we've had in class before. It's dividing by 2 each time. What is this called? You guys remember what this is called? Not when you're multiplying or dividing. What's it called? The other one, yeah, exponential. So this is a exponential keyword for Weston function, okay? So x should be in the yes column, all right? Okay, Luis, give me any other one that you said was a function. Yep. G. What made you think that g was a function? Why do you think it's not a function? Okay. Okay, right. So this is a function because what he said is you put in 1, you get 1. You never put 1 in again and get a different answer. Okay. So this one is also a yes. Good. All right. Give me another one that you know is a function, Jaron. A. Okay. Why is A a function? Passes the vertical line test. So this is, in fact, a function. Very good. All right, give me another one, Talia. S. Going deep. And why is S a function? It's what? Are all increasing graphs functions? No. So why is it a function? You're right that it is. Are all continuous graphs functions? Yeah, go ahead. Right. So once again, Talia, this is the same as the one that Jaron just shared with us the last time. This passes the vertical line test, which means if I take a vertical line and just pass it along the graph, it never crosses more than 1 point on the graph. Okay? So that is, in fact, a yes. Okay? All right. Matthew, give me another one that was a function. Right. Okay. Why? Okay, good. The same input gives you the same output every single time. All right, good. So this is also a yes. All right. Okay, McKenna is not here. So let's go with Alexa. Alexa, give me one that's a function. O? O. Why is O a function? Because it... Okay. Alexa? Uh-huh. Yeah, right. Don't listen to him. You keep going. Yeah, okay, so if you plug in 2 for x, Alexa? No, you got it. Keep going. If you plug in 2 for x, then that would be 4/3. And then what? Yeah, that would end up being -46 2/3. Okay, what makes it a function is if I plug in 2 for x, Matthew, shut up. If I plug in 2 for x, is there a different, will I get a different answer ever? No. So every time I plug in the same number, I get the same answer. Okay? So that means that yes, this is a function. Okay? Okay. Okay. Nathan, give me another one that is a function. N. Okay. Why is that a function? Okay. Class, Jaren, I need your attention up here. No, it's not your fault. We'll do this last one and then we'll finish this up tomorrow. What is weird about this one? Yes, it has a squared, okay? So Nathan, in this case, sadly, this is not a function, okay? Because, for example, if I plugged in 10, so we'll do what Alexa was doing because that was good. If I plug in 10 for x, then what's 2 times 10? 20. And what's 20 minus 4? 16. So when I plug in 10 for x, then I get y squared equals 16. What could y equal if you know that y squared is equal to 16? 4. Or what? Negative 4 because this is squared. So if I plug in 10, then I get y equals 4. But I can also plug in 10 and get y equals negative 4. So it turns out that this one is not a function for that reason. Okay? Okay, we put the cards back in the envelope. Hang on to the pieces of paper that your work is on. Put the cards on my desk and we'll finish this up tomorrow.